let me introduce myself real quick. I'm a developer advocate for Azul Systems. I was formerly before that, I was a subcontractor for the government, and I worked there a long time, but a long time ago, I used to write Java books. So I'm a book author of a few, mainly Javafx. I did write a book related to Java 7 back in the day. So let's see, enough about me. I want to try to get right into, I have to share our community blog place. So has anybody ever heard of Foojay on the panel? No? Great. So Foojay is a community-driven site. It's headed by our director of open source, Herchin Walingha, and he has helped build this this great site, and we're all a part of it, where it allows you to look at the coming releases of OpenJDK, and it also has events calendars like JConf and others. And there's a newsletter coming soon. So we also have a podcast and a Slack channel. So it's nice because if you want to showcase something, you want to write about something, feel free, you can actually contribute. So if you go to Foojay.io, you can actually see a lot that's on there. So there's a whole bunch of really cool tools too. So I encourage you guys, you know, to give it a visit. And if you have something you want to write about, you can actually contribute. So it's a great place to be. All right, so let's get back to the talk. All right, so I just really quick on Zoom, can people, do they know how to raise their hand in the app? I'm just curious, out of everyone, has anybody ever heard of JNI? Nobody? I'm sure somebody has. Oh, good. So, awesome. So I don't know if folks know, but JNI has been around for a long time. And so JNI has been around where since the beginning to actually communicate with C libraries. And it was very much a hassle, and that's what we're going to get into. Enough about myself. Okay, here's the agenda. Okay, so what is the Foreign Access API? Basically, Project Panama, in the beginning, it was about accessing these C libraries, and the problem was they found out that they had to access memory. Basically, this has been about 6 years in the making with all these JEPs related to native access. So as they became, there's still an incubator, even in Java 17, JDK 17. And so the latest is JEP 419. It's the second incubator of the Foreign Function Access API, which is really a culmination of all these JEPs, because in the beginning, they were still trying to figure things out, because the end goal is actually talking to native libraries. But then they come to find out that memory access was very difficult, to try to create memory layouts and and value layouts to map to C data types. Because in native code, what you'll have is you'll have data types that C or Java does not actually fit, you know, if you know what I mean. Like what I mean by that is like some of the data types that we're used to is like an int is 32 bits or a long is 64 bits. Within C, you can actually define things even smaller, or you can create things that don't fit in the conventional data types that we're used to. So trying to model memory was very important. So they found that was very important. So those are really well defined, and that's what led to the latest JEP, which is an umbrella of all this, all these JEPs combined. So yeah, back in the 80s, I'm an 80s kid, by the way. So there used to be a campaign about say no to drugs. And so I thought of the idea of, you know, say no to JNI. Because back then I used to work in a company one time, a long time ago. We had to access Windows DLLs, and it was very difficult. So there was various libraries, and we used JNI, and it was a pain in the butt. And so this is right from the JEP, and one of the goals is to actually replace JNI, if you know, with superior performance and such, because you know there is some layer of indirection, and with the new Panama API, it's even capable of jitting things. So there's, once it can have the symbols loaded and bound, they can actually optimize in some cases. But most cases, if it's direct access, it's just faster. And some of the things, there's performance charts that I don't have, but they're, you know, putting intrinsics to make them more optimized, and they can kind of infer things, and they can inline things. It's pretty interesting, but it's a little bit too low level for me, but it's pretty interesting. So why Panama, or even why JNI? So the main thing is that there are very mature libraries out there, you know, such as like Git, like it's written in a C API to actually talk to Git, the Git command line. Here you have like Leap Motion. I'm going to show you a demo. I created a demo. I'll show you rock, paper, scissors. TensorFlow is written in C. Ffmpeg, which is a way to stream video and sound and things on all platforms. It's written in C. OpenGL, OpenCL. The view of everybody's covering up the slide. I can't see, but anyway, you see Minecraft. That's like kind of awesome. It's actually the LWJGL, the lightweight Java gaming library, I believe. But that framework is what drives Minecraft. And underneath the covers, it's actually JNI, but it's C that talks to OpenGL and OpenCL and such. And also another library that allows you to talk to joysticks and input controls. So the fundamental thing here to explain is that the Foreign Access API talks to the CABI, which is the standard application binary interface, which is a convention or standard, so to speak. And so a lot of the languages actually can expose their APIs to follow the CABI, which is pretty impressive because like Swift, you could write Swift. Typically people know Swift, you know, there's an abundance of documentation, but not much C libraries or documentation in the Mac world. It's kind of weird. But anyway, if you write something in Swift to access something native within your machine, you can actually create a function that exposes it in the CABI, which is basically a C function. It's an annotation on the Swift code that exposes it, and then any C code can actually talk to that library, or Java. So Panama can actually talk to that exposed API, and C++ also. They have a keyword, it's called extern, which exposes that so that C libraries can actually talk to C++ libraries, and Python, CPython, and Rust and such. So here are some of the devices I'm going to demonstrate soon. So here, here's a near NFC device reader. So these are basically RFID tags, and there's certain standards which have memory, and you can actually write to them with this device. I actually have it right here, see? So you could write to it, you could read from it, and you could do pretty fun things with it. And they have them where there's like stickers, and so here is a Leap Motion device, and I've had this device for a long time, and their APIs were written in C++. So what I do is I expose them using the CABI and just expose it as a C function, and then Panama can talk to it, which is pretty cool. The thing that they're doing because of performance, they're going to rewrite the library in C, basically just turn it back into C. I mean, it was originally written in C, and then they wrote C++ over it, and then now they want to rewrite it and put it in C, but there's only a version for Windows. So do we have a question? Okay, I wasn't sure if anybody had a question. So where do you get it? Okay, so basically within JDK 17 and 16, Panama is in there already. But it's in an incubator module. Now, what I'm saying here is when you get the build here, the early access builds of Panama over at here, you're downloading actually a tool that you'll need, which is called JExtract. So JExtract, which I'll explain in a minute, is a tool that is within the JDK, not the JRE, if that makes any sense. So to do any of these tutorials or examples, you have to download the build from here to get the JExtract tool. So someday when some JEP or something is actually going to be put into the spec for the Java when, you know, JDK, and they may put JExtract in there. So if you develop something and you distribute it, it'll still run, you know, granted that you use the incubator module. So if in the end, there's a lot of code, so we may not get to it all, but here is the website of at Foojay.io. I have the project Panama for newbies, and it's basically the tutorial and all the examples. And if you go to the GitHub site, I have the additional examples that talk to Mac. So what do you do after you download it from that build site that I mentioned earlier? You set your Java home and you set your Java path. I think that's standard. Most folks realize they know that. And just to verify, you just run java-version and you should see it say Panama there. That just lets you know that the JExtract tool exists. So to know if the JExtract tool, just type it in. It's in the user Java home bin directory. So here, I'm just going to outline the common switches that I will be using in the demos, which is maybe 4 or 5. I'm not going to use most of these, but when you get into more advanced situations, you'll look those up and use them. So the first option you'll come to mind, it's very similar to like a C compiler or C compiler, where there's a -I. Sometimes when you type it, you can't tell if it's an L or an I or a 1, but it's -I, and that specifies the path in which header files are actually located. So if you're familiar with C programs, like in Java, we have imports. However, in C, they're called includes, and the includes are headers that are actual files that they end in .h. And they reside, like there's typical C standard libraries. Like on the Mac, I'm going to show you in a minute, it's, you have to download Xcode and they put it in a different place. But on Windows and Linux, it's kind of standard. It's in a typical place where they put it. So -D is similar to Java C, where -D is the destination of where the generated class files are going to be. So basically, you have this JExtract tool really does two things. It creates source code, or it creates class files. Basically, taking it dynamically and actually generating class files so that you can run them. Okay, -L is very much like C and C++ compilers and other compilers, where the -L, that's a lowercase l, where you specify a library, such as like when you, I don't know if people are familiar with Brew, but Brew and other libraries, it's similar to like Node.js world, where you have a package manager like npm install blah. But here, you with Brew and other tools, or Red Hat Package Manager, you're actually installing a library, and it would name it exactly the way when you installed it. You say, Brew install TensorFlow, and it'll be the name of the library would be named TensorFlow. So, so sometimes you don't know the names, but you would have to use your tool to kind of list the name of the library that you installed. And typically these are on the Unix world. They're C libraries that, well, I wouldn't say they're always C, but the ones that you want to target are C libraries. But if you're targeting C++ libraries, or even Swift libraries or other compiled libraries, there's a way, I'll show you how to expose them. And so if you just specify that switch, the source switch, it'll just generate the source code of the the header file. So you can only specify, just like in Java, like, well, not just like Java, but when you specify Java space, and then you specify the Java program that you want to launch or run, JExtract is kind of the same thing. You can only target one header file. And I'll explain that in a minute. So what that'll do is look at the header file and go and build Java code that kind of does all the bindings, which is lower level Panama code that talks to the actual C library, which is, using var handles and method handles, things like that. So, okay. So here's a hello world program. It's typical. It might look easy, but let's unpack this. So here is the header for standard IO. It's a header file within the standard C library. So it comes with any computer that has a compiler, it has those built in. So those typically have the printf and the vprint functions within, anything with input or output or reading keyboard input and such. So let's see. So that's the actual signature of the C function. It looks vaguely familiar with Java. So it returns an int, which is similar. The input parameters are, or the function signature says const, which is another way of saying that it's immutable, a reference to a character array. And sometimes they treat pointers and character arrays very similar. And they have a thing called it's like a var verdict. It's another way of saying variable type arguments or variable arguments in Java. So it's kind of confusing because you have this little asterisk symbol that's beside it. But some knowledge, you may have to have some knowledge of C in order to be pretty proficient, but once you get used to it, you'll understand. So, but what's great about Panama is they make all these things simplified. So like when you look at that pattern, oh, in C and C++, they do this all the time. Well, actually C only, because they use the standard IO library to print a character array, which is a null terminated string. It's kind of weird. And in C++, it's a kind of object oriented, and they have another library that they import to deal with strings. It's actually a string like Java. So this is a typical function. And so here we have, everybody should know this. This is kind of simple. This is a environment variable. I just created an environment variable called Mac include because some of the standard libraries that exist are, how Mac is. It has long paths. So there's a directory called that. So here we're actually generating bytecode. We're just like typically if people are on the command line, they're just running a Java program, you point your class path to that class's directory because that's where it's going to dump all these compiled items in there. So like your hello world would also be in there after it's compiled so that you can actually run it. But then what I'm going to show you is, Java's new thing. You can actually run a single Java application, just purely text. You don't have to compile it, which is kind of a neat tip, by the way. So anyway, the -t, we've I don't know if I mentioned that, but this is the class, the name package namespace in Java that you want to call it. So since this is a standard library, I just called it org.unix. I could call it org.carl if I wanted to. So dash I, again, capital I, which includes the where the location of include files are, which we did in the environment variable. Now you can actually add multiple, if there's more includes from another library, say it's installed in another directory, you can continue to specify those. Now, the last part is what you're trying to target is a header file. Now, if you have multiple header files, which you will, and one of the examples is using OpenGL. And so what you would do is you create a text file, because it's interesting in C, in C++, it's sort of like when they say include, it's actually taking a bunch of text and it's just jamming it in. And they have these things called directives, which are actually called guards. So they prevent the other includes from including it again. So it's kind of weird. It's not like import, like in Java. It's sort of, but not. It's literally saying, hey, if I see this standard, if I see include standard io.h, include this text file into it. So it's interesting. So the next one is just creating source code. This is great. It's the same options. It's the only thing different is the switch and where I generated it, the -d, where I want it. Before it was classes, the class compiled stuff. The next thing is, or here, I just want it in a generated source. And in IntelliJ, it detects generated source files immediately. So once you generate the source code, when you write your application, it already puts it in the class path and it already compiles it. And then you can actually jump to it using your navigation within the IDE. So you can actually look at the low-level code that Panama or JExtract actually generated, which is pretty amazing. It's kind of neat. You're tinkering. It's like, you're kind of, it's kind of like Indiana Jones. You're just, every time you dig deeper, you're finding something interesting, like why did they do this, or how did they do this? It's kind of fun because you figure out, So another thing, once you get it, the source code generated, your IDE wants to look at it. And, sometimes it's nice to look at the source code instead of trying to access it without an IDE. So within your compile or your IDE, even NetBeans or Eclipse, they have the compiler settings. What you would have to do, your compiler would actually have to add this module for for JDK 17. So it won't work. So after it's generated, you could use your code completion, and you can actually inspect it and say, oh wow, so where the -t is the package namespace where it dumped the source code, and you could actually import them and use them just like you would in a C program. And that's what the next example is going to be, where we're going to use printf just like we're doing it in C. It's kind of neat because you can actually create memory such as like a double or a struct, or things off of the Java heap, which is pretty incredible, because something like here's an example that why it's kind of important, like some things like the new vector API that's coming out, where they have SIMD instructions, and sometimes the hardware can do a lot more efficient things than you could within the JVM if it's in the heap. But if you did it off heap and you just allowed the native code to actually operate on that space in memory. And then, when you come back from the scope, it calculates it very, high performant. And that's kind of what you want. You kind of want it to do its thing and what it does best and come back, and then you can present it or use the results within Java. So here is, so here's how you basically access Panama code, just like you would in that C program, but this way it's written in, Panama, of course. So what you do is you call this function called new confined scope, and it'll return you, a scope, and it protects this, and it has a closable method. So when it goes out of scope within this try, it'll close that session. So like, for instance, if you're in the C world, or the, native world, you don't want crazy things to happen, like a seg fault or, some locking or something. So this kind of takes care of it for you within Panama. So there's also within, when Panama generates code, it generates a C linker. It's very much loading, all the native libraries into this like lookup. And also it creates these convenience functions like toCstring. So anytime you create something in the C world, you always get a thing called a memory segment. So remember that. So you're going to see these patterns over and over again. So there's like, I'll show you these other objects, but what you want to do, this is not a Java string. So you want to mimic exactly what's happening in the native world. So you're saying you want a null terminated string. This I can't read it because this is covered. Okay, and so it turns it into this with the scope, and it creates this memory segment object. And then within we saw this before. I statically imported it. So a lot of these things that are statically imported, they're available. So the new confined scope is from this object here. And so if you notice, the printf is not Java's system.out.printf, it's C's printf. And if you go to that actual source code that was generated by JExtract, you'll see the low-level code that Panama actually does to talk to the printf function in C. So that's that. And some of the nice syntactic sugar to try to, reduce some of the words. Okay,
hey,
so
Carl,
here.
there was one question on the chat regarding
Sure.
memory segment, which was from the previous slide. So if you want to address it right now itself.
Sure.
It says the question,
yeah,
I'll read the question. I'll read the question
Sure.
for you. So it's the question here is memory segment that you have there. Is heap memory or off heap?
It's off heap. It's off heap. I'm pretty sure it's off. I know that, yes, it's off heap.
Okay.
It's off heap.
That's it. That
yeah, you can actually share in heap and off heap, but typically when the advantages of Panama is you're dealing with things off heap, but you can share things within heap too. So I can't remember all the functions, but there's a thing called an allocator, and that's what this calls. If you look at the underlying code of there's a segment allocator, and you can allocate it any way you want. You know, how many bits, how many bytes, how many follow a struct, things like that. So I hope that answers that. Okay, so to run the program, it's just like how we specified it in IntelliJ in the beginning about compiling. You need to specify the add modules module. Of course, it's still an incubator, but it's still, you know, production ready. You know, you could still use it. The APIs are pretty solid. I mean, which I hopefully will get to. It does have some verbosity that they will plan to eliminate. I'm following the news letter there, and I talked to some of the engineers, and they're gonna clean things up. I mean, it's very usable. It's pretty nice API so far. If they can make it easier, it would be great. But yeah, this switch, enable native access, has to be there because, you know, it's a security thing. You're dealing with libraries. You're trying to, you know, let the JVM know that, you know. So, okay, let's get to some demos. All right. So hopefully we can get to some of this, and there's even more under the hood. So, okay. So everybody has seen my list here. So okay, that's let me cat the other file. Extract. Okay, so I wrote a little script file, but remember I told you guys and gals that here this generates the binary, the byte code, and then this one generates the source code, so that if you ever wanted to have your IDE available, you can actually look at the code and you can actually run it. And that's nice because then you can start exploring. So running that generates, you know, the -t where you will see, you know, the generated right there. I mean, we can run it to see what it looks like. You'll get these warnings, so. And then I guess you guys saw that, which is, you know, pretty standard, right? And it just says hello world, and we saw it in the slides. So I want to go and do some really advanced ones. Okay, so like I said before, because a lot of languages have to follow the C ABI, the application binary interface, it's very standardized, and a lot of languages use it. So Swift, here's an example. Can you guys see this? Let me make sure you guys can see this. How's that?
Yeah, we can see it.
Okay, good. Where am I? Okay. So let's look at this. So that looks simple, right? It's very much like, I guess, Kotlin, or I don't know, some vaguely similar to Java. And so there's this annotation that actually exposes this Swift function as a C function. So C, notice it says C hello, say hello. So if you look at Sage, so here there's a compiler command where you can actually turn it into a native library. You'll see lib say hello swift.dylib. So once that is created, this is native, and that exposed C API, now Panama is able to talk to it. Now, here, these are the standard switches that we've seen, and then you can run this without compiling it with new part of Java. So this looks pretty standard. I just wanted to see what that was, because this is the naming convention similar to JNI, and you still have to load, either use load or load library, depending on your situation. So there's this function called down call. There's also an up call stub, which allows you to do callbacks, which is kind of interesting. That's my rock, paper, scissors demo that I'm going to show you guys in a minute. But so anyway, the C linker, so singleton. So, you're grabbing that annotation of that C function name that we saw in the Swift code. So here, this thing is called a symbol lookup. In the C world, they call them symbols. I think in Java, we sometimes see that in compile errors where it says symbol not found. So their idea of symbols are functions, objects, or static global variables and such. So this basically is calling it using these two parameters. One describes the interaction as a Java program. Yes, I think this one, I'll explain that in a minute. But this is the interaction between the C library, and this is the interaction to the Java world. So you're just describing the method signature. So then you invoke it. So it's just, void on the, no parameters on the right, and nothing returned. So it's just a call. So it's to make it simple. There you go. So, okay, next example. I'm gonna show all these really cool, because in Swift, you can access the text-to-speech API. So if I can expose that as a C API, then Panama can actually talk to it. So that's kind of cool. So let's see, speech. How does it run? I'm gonna cat it for you guys just to see what it looks like. So that looks similar to the hello world, right? So I put little bash on the end to pass in what I wanted to say. So I could just say run. Or does it speak? Oh, okay, I see. I made one because I didn't want it to compile. It takes a while. So hello, Pittsburgh, JUG.
Hello, Pittsburgh, JUG.
Did you guys hear it?
Yeah, I heard it. That was great.
Yeah, we heard it.
Cool. So let's see. So the other one is, I don't know who has Mac here, but do you guys have not new, it's old now, but Macs typically have a Touch ID. I wanted to access the Touch ID, and I thought it was pretty cool. So like, I don't know if you guys see this. Do you guys see the dialog box here?
Yeah.
Yeah, it says identify yourself, and I put my finger there, and boom, it lets me enter. So that's kind of cool.
My Macs are way too old for that.
Yeah. Okay.
Yeah, I have a MacBook Pro from 2012.
Oh, do you?
Yeah.
Okay, you win. Mine's from 2013, so.
Awesome. So, oh, cool. Okay, so I'm going to show, I believe I have two more cool demos I'm going to show you. The next one is going to be the lib or Ffmpeg. Has anybody heard of that library?
Yeah. Yeah.
Yeah, it's pretty cool, isn't it? It gives you that ability to do, it's a, a C library on, for those that don't know, Ffmpeg is a C library that allows you to stream video and sound and such. So you could create an application that has security cameras, or you could actually take the video and you could actually use machine learning and object recognition and all kinds of really cool things, just taking it off of cameras or IP cameras or video. And you could redirect it, you could save it as video. So you could do a lot of really cool things with it. I just need to find it. Oh, here it is. Okay. So another cool thing is, so what I did was I wanted to use Javafx because, I love Javafx. I'm a big fan of it. And yeah, I wrote some books on it. So I wanted to incorporate a window with JavaFX, and I created a library a long time ago just to demonstrate callouts, and callouts are kind of cool. You'll see them in like science fiction movies. So I just mapped it. It's not a great thing, but so like that's me doing a talk somewhere. And then I click on the mouse, boom. Yeah, whoops, I clicked twice. So that's JavaFX overlaid. It's basically the call out library that I made. So it can just overlay that on top of this surface. I can't remember what I put it on. I think I did it on the canvas or image view. I'm not sure. But it's talking to Ffmpeg natively using Project Panama. So that's pretty awesome. Okay, where did I put it? It just disappeared, my window. Okay, here it is. Yeah, zoom, put these guys, it's covering up my, okay, there we go. So, okay. Oh, this is my other example. Okay, that I'm not going to, well, I could show that, but I don't think we have enough time. Let me show you the rock, paper, scissors. That's kind of cool. All right. Somebody have a question? I'm sorry.
There was one question, Carl. So is there a Maven plugin that wraps JExtract?
No, there isn't. Not yet.
Not yet. Yeah, maybe that's what it is. Yeah.
I think that would be a wonderful thing. I'm sure I think there's going to be a lot of really cool tooling that's going to make it super easy to adapt with native libraries. I think I think it's really going to be the future, because not necessarily like super wowing, but people have struggled a long time with JNI. I mean, it's still very useful. There's a lot of mature C libraries that they're not going to rewrite that. They're very fast. They're very standardized. And why not just talk to them directly with Java? You know, I think it's perfectly fine. And I think with Panama, I think it's going to be awesome. Okay. Thing tracking. Okay, so yeah, I have to turn that on. It's a USB, it goes right in, and then it has some interesting things like, so like I didn't write this. This is part of the the tooling that they give you. So so I basically went to their website, and I thought, approaching them, I thought it was like a C library, but that was only for Windows. So they only have the example for in C++. So so this is the way to do it in C++. And like I showed you in Swift, there's an annotation, which is kind of neat. But within C++, this is how you expose a function as a C function in C++. So once it's exposed as a C function, Panama can talk to it. And this is really hard to read. People get really confused, like, what in the world is that? Well, this is the name of the function. Think of this as like a lambda, but it's a pointer to a function. So basically, like a SAM or a single abstract method is basically like a lambda expression or lambda. And so in this case of C language, they always denote the asterisk as a pointer, and when it's declared, but not when it's used. That's actually dereferencing. That's another terminology that we won't go into. But so here you have on shoot so the game is rock, paper, scissors, and people usually say 1, 2, 3, shoot, 1, 2, 3, shoot, 1, 2, 3, shoot, And so I called it on shoot. And this defines in the C, this is really weird, because forget about const, because to Java, it's just a reference, right? It doesn't matter if it's immutable or not. Panama can access that address. And these are called void pointers. And usually the type that is being passed in has to be the same type. Like a function pointer and an object pointer are two different types. Like, so if you're casting these things called void pointers, they have to be the same kind. So like if you're casting this, they're called void pointers. It's a void and an asterisk. These are called void pointers. They're a way, it's like X. It's like, I don't really know what it is. Like they have the compiler is really strange in C. They give you that leeway. It's kind of weird, because like we understand Java and C very strongly typed. And then you have generics, where generics kind of, you still have to define exactly what that type is. But in this case, in C, they give you this option. It's kind of like, well, but the thing still has to be the same kind. If it's a reference to a primitive, it has to be a primitive. If it's referenced to a function, it has to be a function. So I'll explain that, but not a big deal. So here you have the C++ program, and it looks really simple. It's from here to here. So in Leap Motion, they have this concept of a controller, and then they have a listener. And the listener basically is it intercepts frames. So this device, this Leap Motion device, basically shoots infrared light, and it's like a camera basically. And the surface of my hand, it's like taking pictures 100 at a second. So it's basically taking measurements. And so it knows where my fingers are, where my joints are, where my fingers are extended. It's pretty impressive. And so they try to make the API pretty easy. And so this example, yeah, I had to hack it. So that's why the example is called hacked samples. So anyway, this is the frame. So a single frame that is actually capturing the hands or two hands. It could actually, you could move fingers, it's pretty impressive. So each frame is one capture, and it's like 100 or more per second. It's pretty crazy. So once you capture it, you can actually, it's kind of like Java, where dot operator to interrogate the object. You can get the number of hands. So when the game goes, it's in the ready mode, there's no hands in this array. So that's why so anyway, to kind of sum this up, this is kind of advanced, a part of Panama, where it's called up call stubs. So I will show you that right here. So yeah, I don't explain it in the, I only showed you the down call. It's simply calling a function, but this way we're actually creating a static function. I think this is my function. I can't find it, but let me run it and show you what I'm trying to say. It's basically a callback. The idea is basically a callback. So can everybody see that okay?
Yep.
Yeah.
Yep.
I can.
Yeah, we can see it.
I don't know if this is working. Sometimes it doesn't work. So it's like this game, it always wins because it's so fast. So like, okay, you know what this is? This is paper, right? So paper wins scissors, or scissors beats paper, right? So rock, paper beats that. Okay. Isn't that cool? You guys get that?
Yep, very cool.
Cool. Yeah, so this is basically upcall stub, which is it's how to make callbacks. So you're basically creating a Java static function, and you're passing it to the C library to actually call it. It's kind of cool. So it's kind of like passing in a Lambda or a closure and say, hey, whatever library, you call the closure. So it's kind of neat. All right, so let's go back to the slides. Okay, how are we doing on time, Shrisha? Probably out of time soon. So I'm going to try to run.
So we do, we also want to keep some time for the raffle itself at the end. So maybe, I don't know how you're
wrap it up. I'm just going to wrap it up in just a few slides. Just give me,
yeah, for sure.
Because I'm not going to go under the hood or anything. I think I showed you enough. I mean, the hello world. Yeah, if you guys have any problems or questions, feel free to message me and such, because there are some, difficult cases, or if you're targeting 2 header files, you would just create a file and you would put those headers in there. It's a trick the Panama guys showed me. So, okay, here is what is called a value layout. And using the segment allocator, using the scope, which we saw in the try block, you can actually create an allocator object. This allocator object actually allocates the objects off heap. So for instance, a C double, it's similar to a Java double, but here there's different overloaded methods that allow you to, it's kind of essentially creating it and setting pi to that memory location. So, or you could just create it and then you could set it later, which is shown at the bottom. Here I set it to 2 times pi, which is actually, so that those are 2 things you should remember. Is memory segment is how to create things that are on the C or the native world. And then there's the memory access, where you're accessing that memory location that's off heap, using the Panama memory access API. So here's an example, again, where we used the memory access and allocating it. And so that's, it accepts a memory segment. And so here's a way to do arrays. If you have an array in the native language, this is just a fancy way of reprinting the same thing, modding for. But this time I'm using Java's printf because I feel like it. It's very similar. And of course, that takes a memory segment again, same pattern, and then the index of the guy inside the array. And that's the output. So I don't know how much people know about pointers. It's pretty fundamental. Back in the day, it's, the KNR books from the original C language in Unix. So just a brief overview. It's really simple. Think of it as a mailbox, and each mailbox has an address. It's located here in this hexadecimal value. It's basically, it's like a label saying, this is where this location is. And it just has space to put stuff in. And so a pointer, basically, when you assign it, you're assigning the address in C. They take the address of X. So say X is defined as an int or something. And it says, go give me the address of where X is located. X is located here. And the value in here, I don't want the value. I just want the address of it, and put it into this value. So it goes into his box. So that's kind of how C works. And sometimes there's advantages, because you don't have to copy memory. And that's a problem with Java, because everything is in some ways passed by value, or depending, if you're using an object, of course, it's passed by reference. But a lot of times, even if you're just passing in a simple int, in C, you don't have to create a copy of it. You could just give you the address. So it actually is better. It's more efficient in memory. So to represent a pointer in memory, there's a method called address. And so if you in the Panama API, they have these APIs that they accept the memory address. Then you have to know how to interrogate that address. You have to know the type or the how many bytes and such. So that's where it gets tricky, and you'll learn from some of the APIs, they make it convenient for you. This is kind of like a fundamental raw example where it takes 4 bytes, because that's 32 bits make an int on most platforms. So it also depends on the system that you're on too. So if you're on some 32-bit machine or some 16-bit machine, who knows? Because, you know, Java is write once, run anywhere, but then even within Panama, when it looks at in the C linker, it's going to find out that, hey, wait a minute, it's not 4 bytes. It could be, you know, 2 bytes or something. So it depends on the platform. But if you're just dealing with desktop, you're typically dealing with Linux or Windows or Mac, and it's kind of safe to use for an int. So here is another way to represent a record similar to Java's new record in JDK 17. But it's called a struct, and this is how you define it. You don't have to say new object and such. It creates this for you, which is kind of interesting. It's simple on code, but yeah, sometimes simplicity can get you into trouble too. So, but anyway, this is just how to use that. And so to represent a struct, they have something called a group layout. And again, there's that's how you represent a struct. In a memory layout, there's a function, there's a few functions on static factory functions that allow you to create structs. One's called struct layout, and then here's how you define them. And this method actually names each individual thing on there. So these are called value layouts. And so what they consider primitives are value layouts, and then advanced things are more like memory layouts, different types of memory layouts, like group layouts. So here's a low-level example. I know this is kind of under the hood, but here you have something called a Var Handle. And Var Handle is how to access the thing inside the struct. So when you create a struct, you can actually create a Var Handle, and then this is how you define how to walk the object. So it could be nested or, you know, but this is how you walk it. You know, it's just a point. So you got an X coordinate and a Y coordinate. And again, you know, here's a setter or the getters, and then there's other ways. Of course, there's something called a sequence layout, and then you can have an array of structs, which is really nice. So the reason why I kind of trying to present a lot of the APIs are just, you know, sharpening your tools and actually getting more skills in actually, you know, targeting a C function, because sometimes C functions, they're pretty crazy looking, you know, like it kind of, you have to scratch your head sometimes when you're looking at them and you're trying to interpret them. You know, it is a foreign language, so you have to kind of get intimate with the library that it was written in. And so sometimes trying to represent every type of object or struct or pointer, it's very important to try to learn each, you know, way to represent it in the native way. So I believe here, yeah, this is how you create it. It's pretty standard. It's very similar. Use the allocator to allocate it. you get, what do you get? A memory segment. So it's always either a memory segment or a memory access to access it to. So var handles are basically a binding to the native thing. And then you can have getters and setters on it. And JExtract actually generates all this stuff for you. So once you have a header file, it just generates all these, and you don't even need to use these functions if you don't want to. But it's just nice to do it if you know what's underneath the covers. So that's pretty much it. These are the main libraries that you'll encounter. Those are the patterns that you'll see, like memory segment. The C linker has all the primitives and the various C pointers and how to represent it. So if you want to see more and kind of get detailed, I have the blog entries that I showed you guys in the beginning.
Yep, and I also shared them in the chat. I think those 3 parts.
Oh, what about Indianness? Oh, good question. Oh man, I have to answer some of these questions.
Yeah, of course.
Let me answer that one.
Yeah. That's
What
the
about
only-
Indianness? Gosh, I don't know how to answer it. I mean, I kind of do. In JExtract, it determines it based on this. In C, when you look at the actual C file or the .h file, it has directives. It says if defined Windows, if defined Apple, if defined Linux architecture, then it defines these variables. So it's like a conditional. In C world, they call it, I guess they call it directives and pre-compilation instructions, I think. So the idea is to kind of, it's sort of like annotations before you actually get to see your code. It's kind of like AOP, like aspect-oriented programming. It's kind of like you're putting stuff in there, but it's not part of the Java language, it's not part of the C language, but in this case it is. But what it tries to do is it already tells you, because you're on the platform, when you go to compile or when you go to run JExtract, it automatically knows the platform you're on. So when you're generating the underlying bindings, the code already knows Indianness because the header files already know Indianness. So that's the interesting thing. But then sometimes you don't know Indianness if you're doing network programming, right? Like sometimes if a computer is talking to another computer, say across a network, or I don't know, some InfiniBand or some something lower level, you can actually change the Indianness within Panama. So I don't know how to do it, but I've seen like some talks on it about it. So it can be done. So I thought, I mean, I could have sworn like, yeah, I'm not really sure about how to answer certain situations about Indianness because, yeah, it's hard to know because, yeah, at some point you don't know the Indianness if you're getting a stream of bits coming from somebody, and it's like, well, it was on another platform, but you just got to figure it out, So, yeah. Okay, what's the other question?
I think you got everything else. We covered everything
the
else.
plugin, awesome, yeah.
And the memory
Yeah,
segment.
that would be cool. That would be cool. Just right click and you get a Maven plugin within IntelliJ. That would be so sweet. Yeah. I think, yeah. I had more, but I don't want to. I want to try to get, yeah, it was kind of hard to explain because the thing with, I mean, I really wanted to show this, but the idea is that without Panama, I mean, I'm saying not without Panama, without JExtract, you can actually call these things, you can actually call these things, I forgot to show you this example. So like this one is calling, it's called the SDL library, which allows you to talk to OpenGL. So you can actually, this is native, but it's inside, you know, it's called by Java, of course, in Panama. But in some of the other examples I have, I think, I'm not sure if it's this example, but you can actually call, into the using the var handles like I showed you, and there's something called method handles. You can call, like, actually I have the example here. So I just wanted to say that you don't need JExtract, but JExtract just allows you, it kind of does a lot of these things for you. So like, for instance, there's 3 things you need to know. You need the return type, you need the symbol name, and you need parameter signature, right? That's how you get the call site, or the call, the symbol. So if you can describe it, you can actually call it, you know? So it's pretty cool that you could do that without using JExtract. You could use something called a method handle, which we don't have to go into, but you guys can see it at the blog. But it's pretty cool. So JExtract basically takes header files from C, and it just generates a lot of these calls for you. So you don't have to do all these low-level calls like method handles and var handles. So that's kind of like what I wanted to have the big takeaway there. So
did you have you already shared these slides for us, Carl? If you can do that, maybe I can post it on the group,
absolutely,
the meetup group as well, so people can access it at a later point and read through the slides that we couldn't cover, or maybe have another session next year, maybe like a part 2.
Oh yeah,
yeah.
The thing
Yeah,
that
we could do that.
Yeah, the plan was to create a workshop, and we're going to have a workshop in JFocus.
Okay, nice. Oh, next year.
So
okay,
it's going to be longer. It's like, I think, a few hours.
Of course, yeah.
So they're going to go through how to like code these RFID cards and such. So you got like a bunch of keychains, you know, and so it's kind of cool.
That'll be fun.
Yeah.
Cool. Thank you so much, though. I think